This video is about exponential growth and decay. So we're going to model a situation using exponential growth and decay models and predict the future outcomes using exponential growth and decay models. So a quantity is growing exponentially if it increases by the same percentage in each unit of time. This is called exponential growth. So in exponential growth, we're going to use the equation y equals a parentheses 1 plus r to the t. Remember that r needs to be written as a decimal, not as a percentage. So a is going to stand for your principal or your start value. R is going to stand for your rate, which remember needs to be converted to a decimal. And t is going to be the exponent, which stands for time. So let's talk about rounding. When we're looking at our answers, we need to decide how we should round them. So if we are dealing with dollars or years, we're going to round to the nearest hundredth. When we're dealing with people or animals or objects, we're going to round to the nearest whole number. So let's look at some exponential growth equation examples. Number one, you deposit $500 into an account that pays 8% annual interest yearly. Write the exponential growth model for the account balance. So our initial amount, that's going to stand for the A, and the 8% is going to stand for the R. So we have Y equals, instead of A, we're going to put in 500, parentheses 1 plus 0.8 as a percent. Remember, to go from decimal to percent, we move the decimal point 2 places. So we're going to say plus 0.08. And we don't know our time yet, so we're just going to leave t as an exponent. This simplifies to y equals 500 times 1.08 to the t. So now I want to determine what the balance in the account is depending on how many years I put my money in the account. So each year is going to be substituted in for t, and we're going to use a calculator to evaluate. So in A, we would have y equals 500 times 1.08 to the fourth power. So in our calculator, we're going to type 500 parenthesis 1.08, close your parenthesis, and then we went to the fourth power, so we're going to use the caret below the clear sign and put in our exponent 4, hit enter. We're dealing with money. How much money do we have in an account? So we're going to round to the nearest hundredth. Nearest hundredth is 2 decimal places. So remember, we look at the number next to the second decimal place, which in this case is a 4. 4 tells us that we stay the same. So this rounds to $680.24. Now we're going to do the same thing with 7 years. So y equals 500 times 1.08 to the 7th. 500 times 1.08 in parentheses, caret 7. Oops, that was 50, not 500. Notice that our money should be going up. We should have more money now because it's been more years that we're increasing our balance. So our new balance now is $856.91 because the 2 tells us to stay at the number we were at. C, 15 years. So y equals 500 times 1.08 to the 15th power. Round to the nearest hundredth again. Y equals $15,086.08. Number 2. In 2010, the salary of a working at summer camp is $1,800 for the entire summer. Each year you return to work, your salary increases by 5%. What is your salary in 2012? So first we need to make our equation. Y equals, our starting salary is 1,800. 1 plus 5%. So remember, 5% as a decimal, we move over our decimal place 2. So we get 0.05 to the t. I can add that together and simplify, so y equals 1800 times 1 plus 1.05 to the t. So if I want to know my salary in 2012 and we started in 2010, that's 2 years. So I'm going to put 2 in for t. So y equals 1800 times 1.05 squared. So you can use the square button, or you can just use your caret again. 1.05 caret 2. So your salary then for that year would be $1,484.50. Remember, if it only gives you one decimal place, we usually have 2 with money, so we're going to add a 0 at the end. What is the cumulative amount of money you would make ending in 2014? So let's say you work at camp for 5 years, 2010, 2011, 2012, 2013, 2014. Well, we already know in 2010 you're going to make 1,800. And in 2012, we're going to make $1,984.50. So we need to find all of our other ones. So in 2011, that's 1 year. So we're going to do 1,800 times 1.05 to the power of 1. That gets us $1,890. 2013, that's 3 years. So we're going to do 1,800 parentheses 1.05 to the power of 3. Oops, need 1,800. That gets us $2,083.73. Notice that this was a 2, but the next number was a 5, so that's why we rounded up to a 3. And in 2014, this is 4 years. So I'm going to do 1,800 times 1.05 to the 4th power. That gets us $2,187.91. So if I want to know my cumulative total, I need to add all these numbers together. So 1,800 plus 1,890 plus $1,984.50 plus $2,083.73 plus $2,187.91. So when I add those all together, I have a total that I made $9,946.14. Now we're going to switch and we're going to look at what happens when we're losing money. So when we have a quantity decreasing exponentially, if it decreases at the same percentage each time unit, this is called exponential decay. Now, it's the same thing. The only difference here is that instead of adding our rate, for decay, we're going to subtract our rate. So A still stands for the start value. R still stands for the rate as a decimal. And T still stands for time. So let's look at number 3. You bought a car for $18,000. The value of the car will be less each year because of depreciation. So depreciation means that the value of our car is going down. So the car depreciates at a rate of 12% per year, right? An exponential decay model. So I'm going to have y equals, my A value is how much I start at, my rate is 12%. So $18,000 times parenthesis 1 minus, now 12%, 0.12 to the t. So I can simplify 1 minus 0.12 is 0.88. So y equals 18,000 times 0.88 t. So we want to know how much money we have in our car after all of these years. Remember that car values decrease each year, so our money should be getting less and less than $18,000. So for 4 years, we have y equals 18,000 times 0.88 to the 4th power. And that gets us y equals $10,794.52. Make sure that we're labeling it, so I have my dollar sign. 7 years, y equals 18,000 times 0.88 to the 7th. And that gets us $7,356.16, which makes sense. The longer that you own a car, the less it's going to be if I was trying to trade it in or sell it later on. Our last one, 18,000 times 0.88 to the 15th. Nope, 0.88 to the power of 15. So our car is now worth $2,645.53. Number 4, in 1996, Tommy decides to invest $4,000 in the stock market. Each year since then, the stock has decreased at 2.5% each year. If Tommy decides to leave his money, what will the value be of the stock in 2009? Let t equals 0 represent 1996. So first I'm going to write an equation. Y equals, he started with 4,000. So 4,000 times 1 minus 0.25 as a decimal becomes 0.025 to the t. So when I subtract 1 minus 0.025, we get y equals 4,000 times 0.975 to the t. Now, if he is taking out his money in 2005, we can subtract our years to figure out how many years it's been. So 2005 minus 1996, when he first put the money in, that's 9 years. So we want to figure out how much money he has left after 9 years. So we're going to put that in for t. So y equals 4,000 times 0.975 to the 9th power. So 4,000 parenthesis 0.975 to the 9th power. That means if he leaves his money in for 9 years, he's going to have $3,184.94 because he's lost some money in the stock market. So given each function, determine the type and the rate. So remember that exponential growth means that our value is above 1. Exponential decay means our value is less than 1 inside the parenthesis. So in A, 0.96, this means that it's a decay because we subtracted to get less than 1. So to figure out our rate, we got to figure out how did we change from 1 to 0.96. So if it's less than, I'm going to subtract that to figure out what my rate was. So 1 minus 0.96 means that the rate was really 1 minus 0.04. So 0.04 as a rate, I'm going to move my decimal place over to the right 2 places. So this is 4%. So my rate would be 4%. Number 5, y equals 0.05, 1.05 to the t. So this time it's greater than 1, so it's a growth. So to find my rate, I'm going to do the opposite because it's bigger than 1, so I want to know what I added. So I'm going to subtract 1.05 minus 1. That gets me 0.05. Move my decimal 2 places to the right. So my rate would be 5%. Letter C, y equals 5 times 0.07 to the t. So again, this is less than 1, so this is a decay. I'm going to do 1 minus 0.07. 1 minus 0.07 gets me 0.93. So I need to change that into a rate. So I'm going to move it over 2 places. So my rate would be 93% that I decreased in a decay problem. D, y equals 100 times 1.6 to the t. So because this is greater than 1, this is a growth. So we're going to do 1.6 minus 1, which is 0.6. I'm going to change that into a decimal. Notice that I don't have a value here, so I'm going to put a 0. So this would be 60%.